I can still remember all the excitement that I felt as I got close to first flight in the Casset. Naturally, I had some concerns, I had some apprehensions about what I might discover in the course of that flight. And I had a real extensive test plan. I had a number of things that I wanted to investigate on that first mission, but I also had a subset in mind that I could scale down to just in case I discovered something that I didn't like in the course of the flight. In my particular case, I felt that the controls were a little bit light, and I felt like I wanted to come back and check the center of gravity a little bit more closely on that flight. So I flew a subset. I didn't accomplish all the things that I wanted to, but I scaled my plan back and accomplished just a minimum set of the objectives. Any of us need to be prepared to do the same thing in the course of that first flight, but a well thought out test plan is a necessity for any first flight. The purpose of this video is to make your first flights as safe and as rewarding as mine. It doesn't matter if the Homebuilt is new or pre-owned. The success of the mission rests entirely on you. During the course of this video, we will attempt to answer many questions and concerns regarding first flights. Throughout the program, the terms amateur built and home built will be used to describe aircraft issued experimental airworthiness certificates as defined by FAR 21.191G. There are many satisfying challenges involved in making your first flights. We hope to encourage you to approach the task with all the seriousness, foresight, skill, and common sense employed by the long tradition of test pilots, beginning with the Wright brothers.
The initial flight for any aircraft is a test flight. Many pilots may not have the necessary experience to fly that specific aircraft. The probability of an accident is higher in these cases. Even if the airplane is a high-time, pre-owned home built, the first flight is always challenging to the new pilot. Approximately 1/5 of all accidents involving amateur-built aircraft occur during the initial flights. Although the crisis may arise in a fraction of a second, the accident sequence often develops because of errors or poor planning during flight preparation. Plans for the test flight begin before you start working on your home built. The aircraft you select should suit your building experience. Consider the type of flying you plan to do and the sort of airfield you'll be using. Your project should be an aircraft compatible with your proficiency and experience. While you are building or searching for an airplane to purchase, make sure you find time to maintain or improve your flying skills. If the airplane is more complex than what you are used to flying, it's important that you receive training equal to the increased skill level. Too often, a pilot will invest time and money in a project at the expense of flight training and practice. The finished product must be a solid, defect-free aircraft. Many resources are available to augment your own skills and to ensure that construction proceeds smoothly. These include a wealth of FAA documents, help from kit manufacturers or plans designers, clubs formed to support specific aircraft types, and aviation organizations such as the Experimental Aircraft Association and others whose membership is made up of people who share your interest in building and flying amateur-built airplanes. For example, EAA's Technical Counselors Program offers construction guidance from a network of knowledgeable builders. Interaction with such associations or their chapters can help you obtain hands-on assistance in most areas of the country. All paperwork must be completed prior to the initial flight. This includes weight and balance calculations, the airworthiness certificate, registration, operating limitations, builder's logbook, and if necessary, radio license and state registration. Pertinent paperwork must be kept in the aircraft. Along with this paperwork, FAA Advisory Circular 9089A, Amateur-Built Ultralight Flight Testing Handbook, recommends developing a flight test plan. The flight test plan is a list of objectives and procedures for each test flight from the first to the last. In addition to this plan, it is also recommended that you develop cockpit checklists to cover everything from normal procedures, such as starting the engine and landing, to emergency procedures, such as engine failure. When it's time for the first flight, assess your own flying skills. Only you can evaluate your present state of experience, currency, and proficiency. Realize that it's all right to delay the first flight until you receive additional training in a similar aircraft. Or you can have someone else test fly the airplane for you. Don't take unnecessary risks because of peer pressure, eagerness, or a misplaced desire to prove yourself capable. EAA's Flight Advisors Program is an organized support group for pilots making early flights in home-built aircraft, ultralights, and vintage restorations. EAA can provide you with the name of an experienced individual who will guide you through the first flight experience. While the flight advisor will make no decisions for you, this person will help you evaluate the aircraft and the piloting skills it will require. Major Norman Howell is a test pilot at Edwards Air Force Base in California. He has extensive experience with amateur-built aircraft and has performed and supervised a number of home-built first flights and pilot checkouts. The first step is to perform all preliminary power plant and taxi tests. In any test flight sequence, there's plenty to be done before you leave the ground.
At any time that you're working on the engine, you need to be sure that you are very careful around the propeller. There is a possibility that the engine could start regardless of the position of your magneto switches. Check your propeller blades for proper tracking. Each blade should track within 1/16 of an inch of each other. And be sure that you pre-oil the engine. You can do this by motoring the engine without the spark plugs in. This will allow oil to get up onto the cam and into the crankshaft journals. Do a very thorough fuel system check. With the cowling off, pressurize the fuel system with the boost pump if installed and check for leaks. When you're running your engine, be sure to take the proper safety precautions. Install chocks, apply the parking brake if it is available, and have plenty of fire extinguishers around just in case you need them. The first run should be very brief. What you're looking for is for vibrations to shake anything loose in your engine installation, and also for any fuel or oil leaks. Later on in subsequent runs, you can check for a proper idle speed and proper idle mixture setting. Also check to make sure that both magnetos are operational, and check for proper functioning of the carburetor heat. It's also very important to check that you have proper fuel flow with the aircraft in other than a level attitude.
And we're going to do some slow speed taxi. On a slow speed taxi, we don't want to go any faster than a brisk walk. Basically, we're just checking for engine response. Okay, and what we do is we go very slowly here, just check the brakes and the nose gear steering. All the controls should be free, but I'm not going very fast here. I'm just doing real short turns. Add a little bit of power just to get the feel of how the brakes go. Then turn a little bit here. I have good steering. I'm getting the feel of the rudders and the controls. Just getting used to what the airplane is like. It's looking good there. During low-speed taxi testing, it's very easy to get the brakes too high. So what I'm going to do is have my ground monitor come in and check my brakes for me. And I wave him in to come check the brakes. I've already briefed him about work around the airplane with the propeller running. So now he's checking the brakes. Okay, the brakes are good, thank you. I'm setting up for the high-speed taxi now. Your preparations for a high-speed taxi mentally should be the same as the first flight, because it's very easy for yourself to get airborne. I have a ground mission monitor or an airborne mission monitor as appropriate that's ready. It's important that you have the aircraft trimmed and everything is ready for a high-speed taxi. You should never do a high-speed taxi without the engine cowling on or without the airplane in some condition other than ready for flight. Okay, this is high-speed taxi test. Here we go. Power's coming in. Want to look for governed engine RPM if I have a constant speed prop. Engine RPM looks good. The airspeed is off the peg. I have good directional control. When I lift the nose, then I'll reduce power quite a bit. There's the nose starting to come up. Power's coming back. Now I'm rotating. I'm about 60 knots right now indicated. I can hold the nose up. It feels like it wants to get a little bit light. Maybe just a touch light there. I can feel it light, but it feels good. Okay. Bring the power back. I have good directional control. The forces are light. The engine is running good. I'm still at 60 knots. Now I can look the nose back down at about 55 knots. Let's check the brakes. A little bit wobbling back and forth. But the brakes are good. The engine is good. With all these preparations and precautions, your first flight should be a very safe and enjoyable experience.
After all ground tests have been completed, begin preparations for the actual flight. Pick a day when the prevailing wind is aligned into the runway. Avoid high traffic locations. Select a nearby alternate landing site to use if problems occur. The runway should be more than 4,000 feet long and at least 100 feet wide. If you're testing a high-performance, retractable gear home-built, or you intend to operate in a high-density altitude environment, the runway should be more than 6,000 feet long and 150 feet wide. Choose a day with good weather conditions. The best time to fly is usually in the early morning, when the wind is calm and the pilot is rested. Minimize the inherent stress of the situation by eliminating spectators. There will be plenty of time for your friends and family to participate in your flying activities once you've flown off the flight test hours. You do need a ground crew to handle emergencies and monitor your mission. The crew should be involved with the planning and coordination of your entire flight. They should be knowledgeable, capable, and enthusiastic. Contingency equipment should also be available, such as a fire extinguisher, pry bar, or crash axe. We suggest the pilot wear protective clothing, such as a Nomex flight suit, gloves, socks, and helmet if available. If not available, cotton or wool clothing offers some protection in case of fire. There are two types of mission monitors, chase plane monitors and ground monitors. In both cases, radio communication is strongly recommended. If your airplane is not equipped with a radio, a handheld radio can be rented or borrowed. To reduce cockpit workload, the pilot should use a headset with a microphone and a push-to-talk switch on the stick or yoke.
And we're climbing for high key.
In a chase plane monitor situation, the performance of the chase plane must be compatible with a test aircraft. The chase pilot must be an experienced formation pilot who's in complete command of the aircraft. If you do not have access to such a pilot, it's recommended that you use a ground monitor. The chase pilot must not only fly his or her own plane and maintain position on the test aircraft, but must also clear the flight path for both planes, a job normally handled by the flight lead. The role of monitor goes to a second person in the chase aircraft. The monitor's function is to observe the exterior of the test aircraft and alert the test pilot of any hazardous conditions not visible from the cockpit of the test aircraft. Record data and flight conditions as announced by the test pilot. A tape recorder plugged into the intercom system can be a big help here. And to assist in the event of an emergency or radio failure. In any situation where there is intentional close flying, as in the flight monitor situation, the entire flight profile should be briefed and all suitable contingencies discussed and understood. For example, which way should the aircraft turn if loss of power or inadvertent roll or pitch occurs? During the flight, the chase plane crew verifies rough airspeed and altitude readings and records observations. If an emergency situation develops, the monitor suggests courses of action as agreed upon during the pre-flight briefing. If you don't have access to a second plane and pilot, using a ground monitor will allow you to meet many of the chase plane objectives. The disadvantage is the test pilot must convey a significantly greater amount of information to the monitor. Every bit of planning minimizes the risk of an aborted or dangerous flight. Script the entire flight on paper beforehand. Rehearse the flight while sitting in the cockpit. This should be done in collaboration with the ground monitor or chase plane pilot. Finally, give the aircraft a good pre-flight inspection with the help of your mission monitor. Emergency situations such as loss of communications, fuel flow interruption, and controllability loss or limitation do arise, however, and as a prepared pilot, you'll be able to deal with them. By running through the procedures before the flight, you optimize your chances of reacting correctly. Review each system and possible problems in turn.
In the case of a fire, fly the airplane. Shut off fuel and magnetos. Declare an emergency, shut off master switch, and land as soon as possible. In the case of smoke, fly the airplane. If the smoke smells like plastic wire insulation burning, indicating an electrical problem, shut off the master switch, open the fresh air vents to clear the cockpit of smoke and fumes, and land as soon as possible. If the smoke is blue-gray and has an acrid odor like burning oil, shut the fresh air vents or close cabin heat and monitor oil pressure and temperature. Be prepared to shut down engine and land as soon as possible. Loss of power and how to deal with it varies with the airplane and the airport position. In a majority of cases, the problem is fuel related. Fly the airplane. Establish best glide speed and try to restart the engine if time permits. If you're below 800 feet AGL and the engine will not restart, land straight ahead or 20 degrees on either side of the runway centerline. This is suggested because in most cases you will run out of altitude or airspeed if you attempt a 180-degree turn back to the airport. If you're above 800 feet, the chances of making a 180-degree turn to land on the runway or on another emergency field nearby are proportional to the number of practice emergency landings you have made.
What was that?
Someone Juliet, you're trailing smoke, shut her down.
Shut it down now. Throttle off, mixture off, fuel off.
500 AGL speed 100.
Roger. Engine master switch off. Okay, establishing glide, I got the airport made.
You may want to raise these altitudes to 1,000 feet if you're not completely sure of the handling characteristics of the aircraft.
Roger.
If the engine problem is a vibration that increases with the RPM, first, fly the airplane. Reduce power to minimize the effect of the vibration, but maintain airspeed and altitude and land as soon as possible.
Major Pam Melroy is a former C-17 test pilot. She's recently been accepted to NASA's astronaut program. Pam is also a qualified ground monitor, and in the following sequence will assist a pilot experiencing a control system malfunction.
I'm banking left. I'm in a left turn. Something's wrong. I've got no response with the stick.
Use rudder to level your wings.
Roger. Leveling.
Okay, now use power and trim to maintain your attitude.
Roger that, and it is working.
Do you have control?
Affirmative.
Okay, now set yourself up on a nice long straight in. Use your rudder, trim, and power to maintain control.
Roger.
The use of electric trim systems has increased the occurrence of trim failure. Trim may lock in its current position, or it may run away to one extreme or the other. Fly the aircraft. Try to use the appropriate trim to offset the control pressure. Keep the airspeed safely above stall and maintain altitude. Make small control inputs. Reduce power slowly to avoid controllability problems, and land as soon as possible.
Training airplanes, so we'll go over a couple things.
In most cases, the airplane can be flown without instruments. The most critical is airspeed. Because this is your first flight, you won't be able to accurately judge the feel of the airplane. Engine instruments on an untried engine are also crucial, and their failure might be an indication of other problems. In both cases, continue to fly the airplane, use normal power settings, and land as soon as possible.
Okay, my door's popped open.
In some cases, this presents an unsolvable problem. In others, it is only a major noise distraction. Fly the airplane. If the canopy or door has been left open, resist the urge to close it. If the canopy or door is completely detached, Determine if the loss has damaged the aircraft, and if so, it may affect landing performance. Land as soon as possible. This is also another reason to wear goggles and a helmet.
The second flight in your amateur build should be much like the first, except that you've corrected any problems encountered during the previous flight. Subsequent flights should confirm the results of the first flights and explore engine performance, climb and descent effects on the engine, airspeed indicator accuracy, and gear retraction if applicable. It is also necessary to determine how the pitching moments change with gear, flaps, slats, or spoilers, and engine RPM. As you fly additional hours, you will concentrate on stall speed, best rate of climb speed, best angle of climb speed, and slow flight. Remember, there's a wide variety of resources available. We strongly suggest you obtain a copy of FAA Advisory Circular 9089A, which details much of the information in this video. Throughout this presentation, we've adopted a cautionary tone about the first flights in your amateur-built airplane. It's important that you are extra careful during this crucial period. As you know, flying is fun and safe if you plan ahead, do a good pre-flight, and follow proper procedures. Approach your first flights with common sense and careful planning, and you'll be rewarded with a successful and enjoyable experience.